Today's lesson is on stretching, shrinking, and reflecting on the graph of the function of the absolute value, f of x equals absolute value of x. Let's see the effects of the constant a on the graph of g of x equals a times the absolute value of x. This graph is going to change based on this constant. Recall the graph of f of x equals absolute value of x. Let's say I pick numbers like, say, -2. Well, the absolute value of -2 is going to be positive 2. If I pick -1, the absolute value of -1 is going to be 1. And of course, 0, the absolute value of 0 is 0. And if I pick, let's say, +1, the absolute value of 1 is still 1. And the absolute value of 2 is 2. If we plot these points, we can see the graph of the absolute value function. So 0, 0 goes here. And 1, 1 is here. Absolute value 2 is 2. And on the negative side, absolute value of -1 is +1. Absolute value of -2 is 2. So you're going to get a graph like this. Let's see what happens when the constant changes. When the constant's not 1, let's see what happens. For example, now we have a constant of 3. So, let's say I pick, say I try 2 again. Well, the absolute value of 2 is 2. And 2 times 3 is 6. And if I try 1, the absolute value of 1 is 1. And 1 times 3 is 3. If I do 0, you're still going to get 0. Let's say I had -1. Well, the absolute value of -1 is 1. 1 times 3 is 3. And if I have -2, the absolute value of -2 is +2. And 2 times 3 is indeed 6. So let's see what happens when we get those. All right, let's look at the graph of g of x equals 3 times absolute value of x. Now we have a constant of 3. So we're going to plot the points that we had in the chart. We know that when x is 0, y is 0. So that point stays the same. When x is 1, though, y is going to be 3. So I'm going to go up 1, 2, 3. When y is 2, now we get 6. So we go 1, 2, 3, 4, 5, 6. And when x is -1, we still get 3. And when x is 2, we get 6. All right, so the new graph is going to look like this. And if you look at it, it looks like it shrinks from the original graph. The original graph in white is a little bit wider. So it shrinks by a constant of 3. Okay, graph g of x equals 1/2 times absolute value of x. What happens when the constant is 1/2? So, let's say I plug, I'm going to pick an even number. So let's say I pick -4. Well, the absolute value of -4 is +4. and half of 4 is 2. And if I pick negative 2, absolute value of negative 2 is positive 2, but half of 2 is 1. And of course, 0 is going to be 0. And then it reflects. So if I have 2, the absolute value of 2 is still 2. Then half of that is 1. Likewise with 4, absolute value of 4 is 4, half of 4 is 2. So we're going to plot these points. Now the original graph is here. But now our new points. When x is, let's say, positive 2, we go up 1. Well, 0, 0 stays the same. So if I go 2, I go up 1. 4, I go up 2. And I do the same thing on the other side. If I have negative 2, I go up 1. If I go over negative 4, I go up 2. So our new graph looks like this in white. And notice that the new graph is wider than the original graph. So it stretches by a half. You have a fraction constant, it always stretches. All right, what happens when there's a negative in front of the function of absolute value of x? We're just going to change the sign. So let's say I have negative 1. Well, the absolute value of negative 1 is positive 1, but don't forget this, you have to add this constant. Think of this as a negative 1 out here. So negative 1 times 1 is negative 1. If I have negative 2, the absolute value of negative 2 is 2, right? But you still have to apply the negative there. So you're going to get a negative 2. Of course, 0 is going to be 0. If I have a positive 1, the absolute value of 1 is 1. But then I have to apply the negative, so I get negative 1. And likewise with 2. The absolute value of 2 is 2, but then you apply the negative, so you're going to wind up with a negative 2. All right, let's look at the original graph real quick. The original graph went out like this. And now we want to compare it to with the negative in front. So when x is negative 1, I go down 1, I get negative 1. When x is negative 2, I go down 2. When x is 1, I go down 1. When x is 2, I go down to negative 2. So you're going to get a graph that looks like this. And if you look at that, it reflects over the x-axis. This is the x-axis. It just flips over. It's going to reflect across the x-axis. This concludes our lesson for today.